All right, Northern Oklahoma College. This is College Algebra Math 1513. I'm on Chapter 1, Section 5. We're going to talk about solving compound inequalities, and we're going to write our answer using interval notation. All right, let's review a little, let's get a little background information before we go to our assignment. Remember that absolute value equations have two answers. For instance, the absolute value of x equals 5. My solution can be two numbers. It can be x equals 5. Let me write it down here. Or x equals negative 5. Now, why does it have two answers? Remember that absolute value is just a measure of the distance from 0. So if I say some number is 5 steps from 0, well, that could be 1, 2, 3, 4, 5. That could be the number 5. Or it could also be 1, 2, 3, 4, 5. It could also be negative 5. They're both 5 steps from 0. When you're measuring distance, it doesn't matter if you're going to the left or to the right. All that matters is how many steps you took. So either of these are the solution. We have two solutions, two numbers that are 5 steps from 0. Now, what's the pattern for setting up my answer? Well, I could say x equals 5, just as it's written. I just dropped the absolute value brackets. Or x equals negative 5. Now, what did I change? All I changed was 5 changed to its opposite, negative 5. So our second situation is going to be the opposite of our first situation. Our first situation is just as it's written, drop the brackets. Our second situation is just as it's written, but change that number to its opposite. Let's use that same pattern to set this up. Here's our first situation, here's our second situation. First situation, just write it as it is without the brackets. Second situation is just change the 4 to the opposite, negative 4. Now in between here you can put and, some people say or. I'm not going to get into the difference between and or. I don't care which one of these words you use. I mean, there is a difference, but we're not going to go into that in this course. The only thing that I care about for this assignment in this course is that you put what's inside the brackets equal to 4, or what's inside the brackets equal to the opposite of 4, or negative 4. All right, here's an example for your homework problems number 17 and 21. This will help you work both of those. We have the absolute value of the group 2x minus 9, and it's going to be less than 7. We have to find out what our answers are. Well, we split it into our two situations. So I write it as is. I just dropped the absolute value brackets. 2x minus 9 is less than 7. And I'm going to put or. Don't worry about the and or thing right now. Or my 2x minus 9, that's what was in the brackets. I just dropped the brackets, is greater than negative 7. Now notice what I did. I had to change the 7 to its opposite. All right, we talked about that. You also have to change the inequality symbol to its opposite. So if it's less than, it changes to greater than, and vice versa. So let's solve each one separately. I'm going to isolate my x over here. So I'm going to get rid of my 9, and then I'm going to get rid of my 2. Let's add 9 to both sides. 9's gone. 2x is less than 16. Let's divide that 2 off of there. 2 is gone. X is less than 8. There's our first answer. What about over here? Here's my fence. I want to get rid of the 9 and then the 2. Same pattern. So how do I get rid of 9? Let me get that out of there. Add 9 to both sides. 9's are gone. I have 2x is greater than 2. And then divide that 2 off of there. And x is greater than 1. All right, now the instructions say to write our answer using interval notation. We've solved the inequality, but we haven't written the answer the way they want us to. So I need to write an interval notation. It helps me to get a visual of what I'm talking about. Now, you're not required to graph it on this problem, but I recommend using a graph because it gives me a good visual. Now, 1 is less than 8, so I'm going to put it on the left and put the 8 on the right. And I think about what my solution says. My solution says x is less than 8. So they're talking about all numbers less than 8. So we're talking about these numbers in here, and it's going to the left. And it's also talking about x is greater than 1. So we're talking about a circle on the 1, and greater than 1 would head toward the right. Now these two meet and intersect in there, so we're talking about the solution set that is this segment right here. How do I express that segment right there using interval notation? Well, I say I'm talking about the interval. Remember, we're going from left to right, from 1 to 8, and then I put parentheses or brackets around it depending on whether the 1 and 8 are included. 1 is not included, so I put parentheses on its side, and 8 is not included, so I put a parentheses on that side. And there is our answer written in interval notation. Remember, the graph is not required on this. It's just a good idea to get a visual of what you're talking about. All right, an example for number 23. Absolute value of 2x minus 5 is greater than or equal to 1. Situation 1. What's in the brackets is greater than or equal to 1, just as it's written. I'm going to use the word or just to separate them. Or what's in the brackets. Now remember, we have to do the opposite of this and the opposite of that. So the opposite of greater than or equal to is less than or equal to. And the opposite of 1 is negative 1. Remember, you have to do the opposites of that part of the equation. Now let's go ahead and finish our equation. I add 5, 2x is greater than or equal to 6. Divide that 2 off, and x is greater than or equal to 3. That's the first solution. Over here we add 5, 2x is less than or equal to 4. Divide that 2 off, and x is less than or equal to 2. And we've solved our inequality. We just haven't written the answer the way they want us to write it. So let's do that. Again, I like to have a visual. I like to see what I'm talking about. So I'm going to draw a number line. And I'm going to put 2 slashes on it. And since 2 is less than 3, I'll put the 2 here and the 3 there. And I want to see exactly what I'm talking about. Well, in my first situation, x is greater than or equal to 3. That would mean that there's a solid dot on 3, and it would be shaded to the right. My next situation, x is less than or equal to 2. I want all numbers that are less than or equal to 2. That means I put a solid dot on 2, I shade it in, and I'm shading everything to the left. Now, how do I express my answer in interval notation? Well, I actually have 2 intervals. I have this interval here that I have to write, and this interval here that I have to write. Okay, my first interval, I'm going to put a comma in between them. Remember, we go from left to right. When I write the interval, I'm going from left to right in that direction. Well, if I go out to the left, where do I start? I start at infinity. All right, so my furthest left point is infinity. How far do I go to the right? I go to 2. So I'm talking about the interval from infinity to the left to 2 on the right. Is 2 included? Yes. Is infinity included? No, we can't include infinity, so we put a parentheses around. Now, something else to make this interval perfect is we define infinity when it goes this way as negative infinity. And infinity, when it goes to the right, we define it as a positive infinity, or just a regular infinity. So to finish off my interval notation here, I'm going to put a negative infinity. So going to the left, from left to right, I'm going from negative infinity to 2. What about this interval over here? I'm going from 3 out to infinity. And it's positive infinity, but we don't write the plus sign. Is 3 included? Yes, it is. So a bracket. Is infinity included? No, it's not. We can't include infinity, so we put a parentheses around it. All right, so our answer is these 2 sets. In between these 2 sets, we put a U. That symbol stands for union. And the word union means that when you put these two sets together, you've included all of the solutions.